even started recording yet.
Yes.
Oh. Wait, I don't actually want that in the video.
Too late.
Alright. Alright, so this is the fifth free response question in the 2006 AP, and it's about differential equations. And the information they give you in the problem is that dy dx equals 5x squared minus 6 over y minus 2, where y does not equal 2, and the initial condition that f of -1 equals 4, -4. So in part A, it asks you to evaluate dy dx at x equals -1 and the second derivative at x equals -1. So what you do is that because they give you dy dx, all you have to do is plug in the initial condition right here because it's at -1. So you plug in -1 to x, and you plug in -4 for y, and then if you evaluate that, you get 6. So dy dx at -1, -4 is 6. For the second derivative, you have to take the derivative of the derivative. So then you get 10x plus 6y prime over y minus 2 squared. And then you can plug in dy dx for y prime right here. And then if you plug in -1 and -4 for x and y respectively, you should get -9, which is the answer. Well played, Curt. For part B, it asks if it is possible for the x-axis to be tangent to the graph of f. Given if it were to be tangent, then dy dx would equal 0 because the graph would be horizontal, and y would equal 0 because it would be the x-axis. So if you plug in 0 and 0 into the dy dx equation, you would get 0 equals 5x squared minus 6 over -2, which can be simplified into x squared equals -3/5, which is obviously not possible. So the answer is no, it can't be tangent to the x-axis. How long has the video been?
2:30.
Alright, okay. For part C, it asks you to find a second degree Taylor polynomial for f about x equals -1, which means that there has to be an x squared in the answer. So first, they give you f of -1 equals -4. Then you found that dy dx at -1 is 6, and the second derivative is -9. So you just plug it into like the Taylor polynomial equation, I guess. And you put -4 plus 6, x plus 1, minus 9 times x plus 1 squared over 2. It's actually 2 factorial, but it's the same thing as 2. And, what? Yeah. And then, you have to do the plus 1 because around x equals -1, so you just add the 1. And then, do you think that's clear enough? That kind of makes sense. Yeah. For part D, it asks using Euler's method, starting at x equals -1 with 2 steps of equal size to approximate f of 0. So if it's 2 steps of equal size, each step would have to be 0.5. So x equals -1, the change in x would be 0.5, and then because you plug in -1 and -4 to dy dx, you get the slope is 6 at x equals -1. So then if you multiply that by 0.5, you get the change in y is 3. So then you do -4 plus 3, because that's the change, and then the new point at -0.5 is -0.5 comma -1, because -4 plus 3 is -1. Then you do it one more time, so you have -0.5, the change is 0.5 again. If you plug in -0.5 and -1 into the dy dx equation up here, you will get that the slope at that point is 13 over 4. And you multiply that by 1/2 again, you get 13 over 8. And then that's a change in y, so then you add that to -1. And then at 0, you get 0, 5/8. So then you get here that f of 0 is approximately 5/8, because it's Euler's method, it's not exact.
Oops.
You're an idiot.
Now it looks like a butt on a heart.
Alright, we're done. We're done here.